Okay, in number 19, they're asking us to take the derivative of this kind of ugly function right here. So dy dx is going to equal, well, the first thing we probably all see right here is that y is written as a fraction, a quotient of two different expressions that both contain your variable. That means we need to take the quotient rule here first and foremost. So here we go. Bottom is x, and then multiplied by the derivative of the top. This is where things are going to get complicated here. So the derivative of the numerator, let's get going here. 2 to the x. Same base to the same power multiplied by the derivative of that power, that's just 1, so you can ignore that, times the natural log of your base, which is 2. So that's the derivative of the first term in the numerator, and then minus the derivative of the second term, which is 3 to a power. Same base to the same power, gotcha, multiplied by the derivative of that exponent. Now I could write times -1 right here, but what I think would actually be a little bit sharper right there is to recognize that multiplying by -1 is just going to change the sign of that term, so I'm going to make this a plus right here, and that takes care of multiplying by -1 times the natural log of our base, which is going to be 3. Now, we're not done there, guys. Oh, man, I didn't leave myself enough room. All of that is just the first part of the quotient rule here. That was the bottom times the derivative of the top, and then minus the numerator, which is going to be 2 to the x minus 3 to the negative x times the derivative of the denominator, but that derivative is just 1, and again, there's really nothing to be gained by putting that 1 right there, so I'll just leave it out and call that good. All over the denominator x squared. Okay, that's where we stand right now. The next question becomes, is there anything we can do to simplify this mess? And I don't really know that there is, but I'm going to give it a shot here, guys. That big set of brackets that I have here, I can eliminate by distributing the x, and there's really only 2 terms. That's one, and that's one. So I don't think this is going to do much for us, but I'd probably write that first term as x times the natural log of 2 multiplied by 2 to the x. Not real pretty, but okay. And then plus, kind of the same thing right here, x multiplied by the natural log of 3 multiplied by 3 to the negative x. Then I've got this negative sign here. I'm going to distribute in there to get a minus 2 to the x, and then a plus 3 to the negative x all over x squared. And that's where we sit right now, and my only question then would be, is there anything here that's alike, that can be combined, that can be simplified? And I really don't know that there is. So I'm going to sneak a peek here at the solutions manual, guys, and take a look at what they've done here with their answer to number 19. See if there's anything to be gained by that. Not really. Theirs is just about every bit as ugly as ours was. In fact, they actually quit where we were right here. They didn't distribute the x or the negative sign inside there, which is certainly something you can do, but as we kind of saw on the next line, it didn't really accomplish anything. So for that reason, I wouldn't say it's something that you have to do. So I think either one of these forms is going to be perfectly fine for your final answer for 19.